Today we're going to be demonstrating the reactivity of sodium with water.
So sodium is an alkali metal with atomic number 11 and atomic mass 22.99 grams per mole and only one electron in its outermost shell, making it highly reactive.
Sodium is stored in a mineral oil in a bottle within a bag in a can full of gravel for safety. These measures prevent any substances that may react with the sodium from coming in contact with it. If sodium is to be reacted, it is best to remove a bit of the mineral oil from it first. Sodium is a light-colored metal and is very soft. When placed in a cylinder containing water with phenolphthalein indicator, covered by a layer of mineral oil, the sodium sinks through the mineral oil and begins to react with the water. When sodium reacts with water, it forms sodium hydroxide and hydrogen gas according to the equation 2 sodium plus 2 H2O yields 2 sodium hydroxide plus H2 gas. But the sodium hydroxide dissociates in the water to form the Na plus and OH minus ions. The OH minus ion makes the solution more basic. This is why the phenolphthalein indicator changes from transparent to pink. As hydrogen bubbles through the solution, bubbles tend to stick to the sodium, buoying it up through the oil. A glass stirring rod can be used to resubmerge the sodium and continue the reaction. As more surface area of the sodium is exposed to the water, the reaction proceeds quicker and more hydrogen bubbles up. For an occasionally more dramatic effect, sodium can be reacted with water and phenolphthalein indicator with no mineral oil. As the sodium reacts, bubbles form and the phenolphthalein indicator changes color. As the hydrogen bubbles around the sodium, the disturbance created by the hydrogen can ripple throughout the entire container. The sodium occasionally moves around also as force from the bubbles being released propels it through the water. The hydrogen from the reaction can combust as it forms, causing smoke and occasionally a small explosion.
There you go.
As mentioned before, sodium reacts with water according to the equation 2 sodium solid plus 2 H2O yields 2 NaOH aqueous plus hydrogen gas. The recognizable bubbling and explosions associated with the reaction of sodium and water is caused by hydrogen being produced through the reaction, bubbling out of solution, and occasionally igniting as it flows through the air due to the immense amount of energy involved.